So this talk is going to establish how we measure energy in light so that we can further discuss what exactly is happening in the photoelectric effect and why Einstein won the Nobel Prize for it. So, last lecture we discussed that we had a metal with electrons in it, and we need to kick those electrons off of the metal. And this kicking took a certain amount of energy E, and this energy is called the work function. We also discussed that the way we kicked it off is we shone light at the metal, okay? And this light kicked electrons off. So we need to discuss then, how do we measure energy in this light? What is the energy of the light? And there are really two ways of discussing energy in light, and I'm going to discuss both of them. So the first one is called intensity, okay? And intensity talks about the brightness of the light. Basically, the way you can think of it is you look at a dim light bulb in your room, and you can probably look at it and be fine. You may close your eyes and see a small shadow, but it's not a big deal. Now compare looking at that to looking at the sun. The sun will blind you if you look too long at it. And even the slightest instant of looking at it, and you'll get a very large shadow in your eyes. Don't try it. It's not a good idea. It's bad for your retina. And that's because the sun's light is so high in intensity. It has much more energy than your 40-watt light bulb. Okay? So that's one measure of the energy of light. So you would expect then, if you cranked up the intensity of this light, you would get more electrons kicked off. And I'm going to discuss that in the next lecture, what was actually observed, but I just want to highlight in the wave description of light, this is an important measure of energy. So the other measure of energy in light is called frequency. Okay? And this is also comes out of the wave description of light. So basically you can think of light as a wave. And frequency just has to do with how close together the wave is, okay? And believe it or not, that actually determines the color that you see in the light. For example, purple light has a higher frequency than red light. And that also means that purple light has a higher energy than red light. So that means if we took two light bulbs of equal intensities and we shone red light out of one, and then for the other let's make it blue light, that means that the bulb shining the blue light is actually shining out more energy total than the one with the red light. And let me explain then how we calculate the total energy. Basically, we have our photons, okay? As we discussed in the last lecture, light comes in chunks called photons. And we have all these photons going along their way towards, say, your eyeball. You're about to see them. And we want to measure how much energy they give to your eyeball. Well, intensity tells us how many photons there are, basically. If there are only a few photons, things aren't very bright, your eye has a hard time seeing it. And as you crank the intensity up, you get more and more energy because you have more and more little chunks hitting you. And the energy you receive is just the sum of every chunk gives it you its energy, so once we add them all up, you know the total energy. But the other half to this, then, is each little chunk has its own energy stored in that, and that comes with its frequency. So say we have a red chunk, and a blue chunk, and a green chunk, and a yellow chunk. The way we determine the total energy is then we have to add up the energy from the red, the green, the blue, and the yellow. So you see how this is a combination of both the frequency of the individual chunks of light and how many chunks you have, or the intensity. And this is very interesting because it tells you there are two fundamental properties in determining the energy of a light wave. And Einstein, by looking at the data from the photoelectric effect, actually came up with the conclusion that there had to be chunks of light and that energy had to be related to frequency of the individual chunks. And I'm going to discuss this in the next lecture on the photoelectric effect in detail.